Have you ever looked up at the night sky and wondered, what if our tiny blue planet was on a collision course with a black hole? It sounds like something straight out of a sci-fi movie, but what would really happen if Earth fell into one of these cosmic monsters? The answer is far stranger and more terrifying than you could ever imagine. Let's dive in. First, let's get one thing straight. The chances of this happening are practically zero. The nearest known black hole, Gaia BH1, is about 1,600 light-years away. For comparison, our nearest star, Proxima Centauri, is only about 4 light-years away, so we're safe. But for the sake of this cosmic thought experiment, let's imagine a rogue black hole, about the mass of our Sun, has wandered into our solar system and is heading straight for us. What happens next? Well, long before the Earth itself is in any danger, we would feel its effects. The first sign wouldn't be seeing it, because black holes are invisible. The first sign would be gravity. A black hole of that size entering our solar system would be like a bowling ball rolling onto a trampoline where marbles are gently orbiting. Everything would be thrown into chaos. The orbits of the outer planets, Neptune, Uranus, Saturn, and Jupiter, would be violently disrupted. They could be flung out of the solar system entirely, or sent on new, chaotic paths that could send them crashing into other planets. As the black hole got closer to the inner solar system, things would get even crazier. We would see its effects in our own sky. The moon's orbit would become unstable. Tides on Earth would become catastrophic, with massive tsunamis hundreds of feet high sweeping across continents, caused by the immense gravitational pull. Earthquakes and volcanic eruptions would become constant as the very crust of our planet is stressed and strained. The asteroid belt would be scattered like dust, sending a deadly rain of asteroids towards the inner planets, including Earth. Our planet would be facing a global bombardment event, unlike anything in its history. At this point, humanity would know its doom was approaching. The black hole would still be invisible, but its location would be obvious from the gravitational chaos it was causing. We'd see stars behind it appearing to bend and warp, an effect called gravitational lensing. As it got even closer, an accretion disk might form. This is a swirling, superheated disk of gas, dust, and debris perhaps from a gobbled-up planet or asteroids, spiraling into the black hole. This disk would glow brighter than 1,000 suns, bathing our solar system in deadly X-rays and radiation, sterilizing the surface of our planet long before we ever reach the black hole itself. But let us assume Earth somehow survives this apocalyptic prelude and continues its journey towards the black hole S-event horizon, the point of no return. This is where things get really weird, thanks to Einstein's theory of relativity. As we approach the event horizon, we'd experience a phenomenon called spaghettification. It's a grimly descriptive name. The black hole's gravity is so extreme that the pull on the side of Earth closer to it would be immensely stronger than the pull on the far side. This difference in gravitational force is called a tidal force. This force would stretch our planet, pulling it apart like taffy. The oceans, the atmosphere, the very rock of the continents would be stripped away and elongated into a long, thin stream of atoms, spiraling towards the black hole. From a distance, it would look like Earth was being unraveled into a glowing noodle of plasma before being swallowed. It would be a silent, brutal, and final end for our world. But what if you were an astronaut, watching this unfold from a safe distance in a spaceship? This is where time itself starts to bend. According to the theory of relativity, massive objects warp space-time. The stronger the gravity, the slower time passes. From your perspective, as you watch Earth fall towards the black hole, you would see its final moments happen in slow motion. The light from Earth would become redder and dimmer, a process called gravitational redshift. Eventually, just as it reaches the event horizon, the image of Earth would seem to freeze, fading over an infinite amount of time until it disappears completely. You would never actually see it cross the event horizon. Now, let's flip the perspective. What if you were on Earth as it fell in? For you, time would feel completely normal. You wouldn't feel time slowing down. Looking back out at the universe, however, you would see the history of the cosmos flash before your eyes. The light from distant stars and galaxies would be blue-shifted, and you'd see their evolution speed up, playing out like a fast-forwarded movie. You'd see stars being born and dying, galaxies colliding, and maybe even witness the very end of the universe itself in the final fraction of a second before you cross the event horizon. So, you've survived spaghettification somehow, and you've crossed the event horizon. What happens now? Honestly, nobody knows for sure. Our current laws of physics, including Einstein's general relativity, break down at this point. The event horizon is a one-way door. Nothing, not even light, can escape its pull once it has crossed. Inside the event horizon, all paths lead to one place, the singularity. This is the center of the black hole, a point of theoretically infinite density where all the mass of the black hole is crushed into an impossibly small space. What is the singularity? Is it a tear in the fabric of space-time? A gateway to another universe? Or simply the ultimate cosmic dead end? We don't have the physics to answer that question. Some theories, like string theory, suggest that the singularity isn't a point at all, but perhaps a vibrating loop of energy. Other wilder theories propose that black holes could be wormholes tunnels through space-time leading to another part of our universe, or a different universe entirely. But even if it were a wormhole, it's not the stable, traversable kind you see in movies. The same tidal forces that caused spaghettification would still be at play, and they would be infinitely strong at the singularity. Anything that falls in, whether it's a planet, a star, or a person, would be crushed out of existence long before it could find out what lies on the other side. The information that made up Earth, every atom, every memory, every book ever written, would, according to our current understanding, be added to the mass of the black hole and effectively lost to the universe forever. So, if Earth were to fall into a black hole, the journey would be a symphony of destruction. First, orbital chaos and a planetary bombardment. Then, extreme radiation from an accretion disk. Next, the terrifying process of spaghettification, stretching our planet into a stream of atoms. For those falling in, a final, fleeting glimpse of the universe's entire future before being crushed into the singularity, a point where our understanding of reality ceases to exist. It's a humbling and awe-inspiring thought. It reminds us of the immense power and mystery of the cosmos, and just how fragile and precious our own little corner of it is. While the scenario is purely hypothetical, it pushes the boundaries of our knowledge and imagination. It is a stark reminder that the universe is governed by forces so powerful they can bend time, stretch space, and swallow worlds whole. Thank you so much for joining me on this cosmic journey into the unknown. If you enjoyed this exploration of the universe's extremes, don't forget to hit that like button and subscribe for more deep dives into the mysteries of space. Let me know in the comments what other cosmic what-ifs you'd like to explore next. Until then, keep looking up